All right, today we're in 3-6, which is very similar to what we did last time. Like, it's basically a review. Except this time, we can find zeros that are imaginary, which you could have found last time anyway, right? Most of them didn't do that, but they could have. So 3-6, okay? Yeah, we're just gonna look for some zeros today. Just looking for some zeros. You guys look so excited to be here. I'm excited to see you guys. You guys look all PK and stuff. All right. Let's do this one. That is correct. And you might be saying, where did 3-5 go? Remember, that was the day I was absent. Because that was the easy one that you could do by yourself, right? With the imaginary numbers. Okay. So, we're going to do a lot of the same. But, if you see things that you can do, you should try them instead of guessing. Because, as we just did last time, finding those rational zeros was a lot of guesswork, wasn't it? And it kind of gets frustrating, doesn't it? Okay? And I agree. And I think I kind of showed you guys by me not looking at sometimes and saying, oh, this was a zero, and just forcing it down, I showed you that I can't even find them every time, right? You do have to guess. That is the proper work to go through. Hopefully on your test, once again, I don't know. Hopefully they don't give you a bajillion factors, because then that just sucks. Right? Hopefully it's something like this where it's just 4 things to choose from. Does that make sense? Okay, but the nice thing about this, anytime I see something in 4 terms, I might want to start by what we call factor by grouping. You guys remember factor by grouping? We group the front 2 and the back 2. What does our front 2 have in common? They have an x squared. I'm left with an x minus 3. How about the back guys? What do they have in common? They have a 1. Look how nice that is. Because then that gets rid of the guesswork, doesn't it? Okay? So therefore, that's x minus 3, and this is x squared plus 1. Okay? I am trying something new today. I'm putting the old recorder, the old computer closer to see if we get better video quality. Okay, can we see one of our zeros? What's one of them? 3 is really easy to see, right? So, what about this guy, though? Huh? He is an imaginary number. Okay? And if you're not quite sure how to do them, how could you find them? Quadratic formula, x equals negative b plus or minus square root, right? Or, this guy, because see how it has no x terms? I can just set him equal to 0. How do I get rid of a squared? Square root. And whenever I take a square root, what needs to happen? Plus or minus. So x equals plus or minus I as well. So our zeros are 3 and plus or minus I. I'd like to review some things that we did last time a little bit. One of those things was Descartes' rule of signs, if you recall. How did we find, using Descartes' rule of signs, how many positives and negatives there were? Well, we look at the sign changes, right? Notice I have 1 sign change, 2 sign change, 3 sign change. Does everybody see that? So what does that mean? We have 3 or 1 positive 0. Good morning. Okay, how do I find the negatives? If you recall, I replaced the x with negative x, right? And what happens is basically the things with odd powers are the ones that are going to switch signs, correct? So therefore this would be negative x cubed. He would stay the same. He would switch, and he's there. How many sign changes do we have now? We have none, because they're all negatives, aren't they? So that means I have 0 negatives. Now let's look at our solutions and just see. What do we have right here? I have 1 positive and 2 imaginary. Could we get that pair from what we have up here? 1 positive, 0 negative represents then 2 imaginary solutions. Okay. I would also like to show you that if, once again, it was x cubed minus 3x squared minus x plus 3, or is it the other, or was it plus x minus 3? Was it that way? Okay. I'd like to show you using synthetic. If they give you an imaginary solution, I can still use synthetic to find zeros. Okay, here we go. So this is 1, negative 3, 1, negative 3. One of our zeros was I, correct? So let's check it. 1. What do we do here? We multiply. What's 1 times I? I. Then what do we do here? Add them. Okay, what else do we do? We multiply, so that becomes negative 3i. And then what's I times I? I squared, and that is negative 1. 1 minus 1 is 0, so I'm left with negative 3i. And what's I times negative 3i? Negative 3i squared, which then becomes 3. You can still prove via synthetic, okay, with imaginaries or irrationals just as well. Well, notice, though, this was x cubed. What does this stand for? X squared. But this is nasty. I wouldn't be able to factor something like that, would you guys? Well, you could. That's not fun. So what do we always know? I don't know if you guys know. If you ever have an imaginary solution, who comes along with him? Always. His conjugate. Okay? Who would be the conjugate of I? Negative I. And as we do this one, here we go. Negative I times 1 is negative I. Negative 3 plus I minus I becomes negative 3. Negative I times negative 3. 3i, and we get 0. Notice this was x cubed. This is x squared. What's this? Just x. And so notice here's my zeros that I've already picked, right? And so they're off here. X minus I. X plus I. And then our last one is x minus 3, which we already have. So if they ever give you imaginary solutions as a 0 already, you could still use synthetic to go through it. Or another option is, I'm going to just show you all the options of how you can use it, okay? The other option is if they tell me I is a 0, we also know that negative I is a 0. Once again, right? If I told you 4 minus 5i is a 0, who else is a 0? 4 plus 5i. Conjugate pairs of imaginaries always come together. And does anybody know why they always come together? When do you get an I? When you took a square root, right? And when you take square roots, what has to happen? Plus or minus, and that's why you have conjugate pairs. Does that make sense? Okay, so here's the other way. So if they give us these as zeros, I could write this as x minus I, x plus I. Let's go ahead and distribute this. I get x squared, and because they're conjugates, remember the inside terms cancel, right? You guys remember that? Negative I times I is negative I squared, which is plus 1. Okay? So now I have something that if I wanted to as well, that is a factor. So if I do long division, which was x cubed minus 3x squared plus x minus 3, correct? Is that right? Okay. If I go ahead and go through long division, I have how many times does x squared become x cubed? X. Switch my signs. How many times does x squared become negative 3x squared? Negative 3. So that would be negative 3x squared minus 3. Switch my signs. Notice I get 0. And there's my other 0. So there's multiple ways to do so. If you don't like to go ahead and do synthetic with imaginaries, Then go ahead and get their factored form, distribute it through, and get a term, a trinomial or a quadratic, because that's where it'll be at. And then you could just do long division. Okay? Many different ways that you could go through that. You guys see how all different ways were able for me to find out other zeros, right? Okay. Okay. So this one, there's no tricks to it. Okay, we just got to do what we did last time. So, what are we going to do first to find our zeros? We're going to list out our possible rationals, right? Where's that come from? The P over Q situation, right? Which my P is plus 4. So that's plus or minus 1, 2, 4, divided by plus or minus 1. So our options are plus or minus 1, 2, 4. Good morning. All right. What's a zero that we could try? Well, if we wanted to first, we could check and see what's my first one I always check. 1. Why is 1 the first one I check? Because I can just add the coefficients, right? When I add 1, negative 2, and 4, I get 5. 1 comma 5. All right? I might want to do Descartes' rule of signs really quick just to check. How many sign changes do we have just on its regular function? We have 1 sign change, 2 sign changes, so I could have 2 or 0 positives. That kind of scares me sometimes because if there's 0 and I go search all of them, I'm like, ugh, you know what I mean? So that kind of, when I see a 0, sometimes I stay away from that for a minute. Let's go ahead and try the other way. Okay? Notice when I do Descartes' rule of signs as well, I plug in a negative, and this will give me negative x cubed plus 2x plus 4. Noticing anything with an odd power switched its signs, correct? Okay, how many sign changes do I have now? 1 sign change, so that means I have 1 negative. I have 1 negative for sure. Now, does that negative have to be a rational 0? Does it have to be rational? Not necessarily. Okay, but that limits me down. I can check one of my 3 choices there, right? Let's go ahead and do so. 1, 0, negative 2, 4. What choice would you guys like to try first? Should we try negative 1? What the heck, we'll try it. Oh, that didn't work, did it? Okay, but we don't just stop there. We don't give up. We keep trying. Let's go ahead and try negative 2. Hey, we got one, didn't we? Okay, so one of our zeros is x minus 2, or excuse me, x plus 2, which is 0. Where, what's left over? This was once again an x cubed. What's left over down below? An x squared minus 2x plus 2. Okay, well, always at this stage, what can I always do? Either A, factor, or B, quadratic formula. If you wanted to, you could do completing the square. If you wanted to, Mr. Jones loves a good completing the square. In this case, completing the square wouldn't be too bad, to be honest, but I still like the quadratic formula personally. It doesn't factor because the factors of 2 cannot get me to be 2, can it? So I'm going to do the quadratic formula. X equals negative b plus or minus square root of b squared minus 4 times 1 times 2 all over 2a, which is 2. So I'm at 2 plus or minus. I have 4 minus 8, which is negative 4. What's the square root of negative 4? 2i all over 2, because this comes out to be the square root of negative 4. And what do those guys all have in common? 2. So I also have 1 plus or minus I. So what are my 3 zeros? Negative 2, 1 plus I, 1 minus I, and negative 2. Those are my 3 zeros. And shouldn't I have 3 zeros because it's raised to the x to the third? Our degree is 3, so I should have that, right? That was like a little smirk. Where did I lose you?
Well, you said there's 3 zeros.
Oh, did I? 1, and then 1 plus I, that's the second. 1 minus I is the third. That's where I got x plus 2 gave me negative 2. Right? Does that make sense? Is everybody there? Okay. What if they asked you to put these in factored form? How would I do that in factored form? Okay. I would have x plus 2. Now really, what's the procedure of how I got a negative 2 to x plus 2? I just added them over to the other side, correct? Technically, I sat right here and I said, oh, I'm going to plus 2 because I want to make that equal to 0 so that it shows that it is a 0, right? I also want to do it with these other guys. I want to go x equals 1 plus I. So how do I get this side to be 0? What would I do? Subtract the 1 and subtract the I. Does that make sense? So that would be x minus 1 minus I. And then I also have x equals 1 minus I. So if I subtracted the 1 and added I, I'd have x minus 1 plus I. That would be in factored form. Okay. How's the conversation on the phone today? I don't know. I just see your thumbs are like almost burning. You could start a fire pretty quick. How fast they go. How are we doing? We okay? No? Nobody wants to chit chat? Alright, that's fine. I can't get you guys to talk or whatever. This is like the hardest class to get people to talk. Never had that in my whole situation, my whole life. Alright. Okay. Alright. So on this one, we're still finding all of our zeros. But this one has something a little bit different that's actually pretty nice. What does one of our zeros automatically? Can anybody see it? No, not necessarily. Those have a 0 coefficient. But what does all of these have in common? An x. They also have a 3 in there, don't they? They also have a 3 in there. If you can, always factor something out if you're able to. So I'm able to pull out a 3x. I'm left with x to the 4th plus 8x plus 16. 8x squared. Notice one of my zeros is 0 himself, right? Itself, I guess. I don't know what has a gender, but those are some cool boots. Okay, what would we try here? It looks like a trinomial. Maybe it could factor, right? What's the factors of 16 that might get to 8? 4 and 4. This is actually x squared plus 4 times x squared plus 4. Why are you giggling? Which is another way to write it as this. So notice even our imaginary solutions can have multiplicity. Because the imaginary solutions are plus or minus 2i. Because if I set this equal to 0, that'd be plus or minus 2i. Okay, so 3 out of my 5 zeros are 0, negative 2i, positive 2i, but I'm missing some, aren't I? I need 5. Well, that's where this squared comes in because it's a multiplicity, meaning plus or minus 2i are multiples of that, right? So is there technically 5 zeros there? There are. Okay. Yeah. Nope. What makes this guy 0? 0, and then plus or minus 2i. How do they add up to be 5? Okay. So because this guy's squared, how many zeros are coming out of x squared plus 4? 2, but then I have it again, so that's 4 plus the other 0, which is 0, makes it 5. Good? Okay. Excuse me. Pardon. Hello, Mr. Hookie. How are you? Okay, we're going to find all the zeros. How many zeros should I have at the end of the time? 4. Are they always going to be rational? Could there be irrational? Could it be like square root of 5? Sure. Could there be some imaginaries in there? Sure. Okay. Well, let's look at our P and Q and search that really quickly. What would be our P and Q choices? Our P is plus or minus 1, 2, 4, divided by our Q, which is plus or minus 1 and 3, right? So our choices are plus or minus 1, 2, 4, 1/3, 2/3, 4/3. Now, a hint that I'd like to talk to you guys about. Do you see how 3 over there is a prime number? That means one of these 6 choices has to be it. Kind of, not has to, I guess, because they could be, I guess, in the imaginary or the irrational stage. But there's a good chance that one of these guys is going to work. Can anybody tell me why? Because one of the binomials has to be 3x parenthesis with something, right? Does that, you get what I'm going at? It has to be there. That's the only way to get to 3x cubed is when I have a 3x there. So if this was a 4, then 4/3 would be it, or negative 4/3. Or it could be 2/3 or 1/3. Does that make sense why I might want to choose one of these 6 options? Okay? All right. Anybody have a choice on what you want to try? 1/3? We can try 1/3. By the way, that is one of them. I wanted a little bit of more of a struggle, but whatever. You guys are good. Let's do 1/3. So he would be 3. He would be 1. Right? Hey, how are you?
Good.
You living the dream?
My dream.
That's good. That's all it needs to be.
And not be their dream, but it's mine.
I totally agree.
Okay.
I write that down right? Hold on. I'm going to make sure my coefficients are right. Quick. Do I have 3, -2, -1, -12, -4? Right there, I think we're going to get a little nasty, people. Here we go. Fun times, huh? Is this going to come out, you think? I'm going to say no. We're going to erase that. We're going to erase that. Let's try -1/3. And the reason why I saw -1/3, because when I times this, I get -1, and notice how that becomes 3 again? That becomes a little bit prettier, doesn't it? And then what's -1/3 times -3? 0, right? Or excuse me, 1. This becomes 0. That's what I was thinking in my head. That becomes 0. That becomes -12. That becomes 4. That becomes 0. Pretty cool, huh? Well, it's not necessarily because they're changing, but because as soon as you see the 0, it's not changing, because 0 doesn't have a positive or a negative value, so that means I could go less than that. Okay. All right, out of my options, I checked a third. Anybody else want to try something else? What up? How about 2, just so we can keep going? The reason why I'm choosing 2 is sometimes I work backwards. Okay, and how do I work backwards? Is like this has to be a 12, huh? For me to be 0. What times something can get me 12? Okay, a 2 might be there, so let's try a 2. And notice, voila! There, huh? So, by the way, this was x to the 4th, this was x cubed. What's this mean now? X squared. So what should I do? Should I still search and find? What should I do at this stage? Go to quadratic or factoring, huh? Can the factors of 6 get to be a positive 3? Excuse me, factors of 18 to be a positive 3, not when they're both positive. So, quadratic, here we come. And you're going to do quadratic quite a bit today. So we have x equals -b plus or minus square root of b squared. That's 9 minus 4. A is 3, c is 6, all over 2a, which is 6. This guy right here is 9 minus 72, -63. Everybody see how I got that? And if you don't know, that's -3 plus or minus 3i root 7 all over 6. How do I know it's 3i? Well, what's 63? 9 times 7. And what's the square root of 9? 3, but because he was negative, it's going to be an I, right? And what do all three of those things have in common? 0. So that would be, oh my hell, 3. So those all have a 3 in common. So there's 2 of my zeros. One of the other one was negative was it -1/3? Is that what it was? And 2. There's 4 zeros. You can see how it's very similar to what we did last time. Just doing more, right? With the possibilities of having it. Okay. Okay, we're going to write a polynomial. With degree 3. And you have zeros of 1/2. and 3 minus I. So can somebody tell me my other 0? Does everybody understand how Ben said 3 plus I? Why? It's an imaginary solution. Remember, its conjugate will always come with us, right? Does that make sense? Okay, so here's what I'd like to do. Zeros of a half. How do I write that? X equals a half. X equals 3 minus I, and x equals 3 plus I. What you want to do is put this in factored form. Okay? So when I put this in factored form, we usually don't just write x minus a half. By the way, we're going to times by 2 and subtract the 1. Does that make sense? I times by 2 and subtracted the 1. Yes, no? Feel good? Okay. Then this guy would be x minus 3 plus I equals 0, and x minus 3 minus I equals 0. So therefore, here are my factors. Who would you guys multiply together first? I would multiply the ones with the imaginary solution. Okay? When I do so, I get x times x is x squared, minus 3x, minus ix, minus 3x again, plus 9, minus 3i. Plus ix. Oh, that should be a plus. Sorry. Minus 3i. And then I have negative I squared, which is plus 1. Okay? Combine like terms, I get x squared minus 6x plus 10. Anything with an imaginary solution, especially because these are conjugates, right? All the imaginary parts will always get rid of each other. So if they don't, you did something wrong. Okay? And then we also have this 2x minus 1. Are we there yet? Do we have our equation? Just need to do one more thing, right? Distribute it through. 2x cubed minus 12x squared plus 20x minus x squared plus 6x. This is a plus, I don't want to do it like that. Minus 10 to give me 2x cubed minus 13x squared plus 26x minus 10. There is our polynomial. Any questions? Is that a hard day? Basically the same thing, just adding imaginaries and irrationals in with it. Okay? Chloe, will you go down to the coffee center and grab my stuff really quick? Because you're so kind. Any of you guys want me to do another one, or are we okay? It's just finding that 0. A lot of times you're going to find one, and then you're going to do quadratic to find the other 2. Okay?